Some of the most transformative discoveries in human history were never planned. They were not the result of years of deliberate research leading to a perfectly predicted outcome. Instead, they emerged from spilled chemicals, forgotten petri dishes, and moments of pure curiosity about something that went unexpectedly wrong. The story of human progress is, in many ways, a story of beautiful accidents. These moments remind us that the universe often has a better plan than we do, and that paying attention to the unexpected can change the world forever. What follows is a journey through some of the most remarkable accidental discoveries ever made, each one reshaping civilization in ways that nobody could have anticipated. In 1928, Scottish bacteriologist Alexander Fleming returned to his laboratory after a vacation and noticed something unusual. One of his petri dishes, which had been left out and contaminated with mold, showed a strange pattern. The bacteria surrounding the mold had been destroyed. Rather than discarding the dish as a failed experiment, Fleming examined it closely. The mold was identified as Penicillium notatum, and the substance it produced was capable of killing harmful bacteria without harming human cells. Fleming had accidentally discovered penicillin, the world's first true antibiotic. This single moment of curiosity over a ruined experiment went on to save an estimated 200 million lives. Before penicillin, even minor infections could be fatal. A small cut, a tooth extraction, or a simple case of pneumonia could end a life. The discovery fundamentally altered medicine, giving doctors a weapon against bacterial infections that had plagued humanity for thousands of years. Fleming's willingness to investigate rather than ignore the accident is one of the most consequential decisions in scientific history. In 1895, German physicist Wilhelm Röntgen was experimenting with cathode ray tubes in his darkened laboratory when he noticed something extraordinary. A fluorescent screen across the room began to glow, even though it was not in the direct path of the cathode rays. Röntgen realized that some unknown form of radiation was passing through objects and causing the glow. He called it X-radiation, using the mathematical symbol for an unknown variable. When he placed his wife's hand between the tube and a photographic plate, the resulting image showed the bones of her hand clearly, with her wedding ring visible around one finger. His wife reportedly said it looked like she was seeing her own death. Within weeks, the discovery spread across the world. Hospitals began using X-rays to see inside the human body without surgery. Röntgen received the very first Nobel Prize in Physics in 1901 for this discovery. What began as an unexplained glow in a dark room became the foundation of modern medical imaging. In 1945, engineer Percy Spencer was working for the Raytheon Corporation, testing a military radar technology called the magnetron. While standing near the active magnetron, Spencer reached into his pocket and discovered that the chocolate bar he had been carrying had completely melted. Intrigued rather than frustrated, Spencer began experimenting. He placed popcorn kernels near the magnetron, and they popped. He then tried an egg, which exploded from the rapid internal heating. Spencer quickly understood that the microwave radiation emitted by the magnetron was capable of heating food from the inside out. Raytheon filed a patent for the microwave cooking process, and the first commercial microwave oven was introduced in 1947. It stood nearly 6 feet tall and weighed over 750 pounds. Decades of refinement eventually produced the compact countertop appliance found in kitchens around the world today. A melted chocolate bar in an engineer's pocket sparked a revolution in how humanity prepares and consumes food. In 1941, Swiss engineer Georges de Mestral went for a walk in the Alps with his dog. When he returned home, he noticed that both he and his dog were covered in burrs, the tiny seed pods from the burdock plant. Rather than simply pulling them off and moving on, de Mestral examined the burrs under a microscope. He discovered that each burr was covered in hundreds of tiny hooks that latched onto the loops of fabric and animal fur with remarkable tenacity. This observation sparked an idea. If nature could create such an effective fastening system, perhaps it could be replicated artificially. After years of experimentation with various materials, de Mestral successfully created a two-sided fastener, one side covered in tiny hooks and the other in tiny loops. He named it Velcro, combining the French words for velvet and hook. Today, Velcro is used in everything from children's shoes to spacesuits, a testament to what a curious mind can find in an ordinary afternoon walk. In 1879, chemist Constantin Fahlberg was working at Johns Hopkins University, conducting research on coal tar derivatives. After a long day in the laboratory, he sat down for dinner without washing his hands. When he picked up a piece of bread, he noticed it tasted remarkably sweet. He rushed back to the lab and began tasting everything on his workbench, eventually tracing the sweetness to a compound he had accidentally synthesized earlier that day. The compound was benzoic sulfamide, which he later named saccharin. It was approximately 300 times sweeter than sugar and contained no calories. Fahlberg patented the discovery and began mass production. Saccharin became the world's first artificial sweetener and laid the groundwork for the entire artificial sweetener industry. It became especially important during wartime sugar shortages, and later as a dietary alternative for people managing diabetes. A forgotten hand wash before dinner gave the world a sweetness that required no sugar at all. In 1968, Spencer Silver, a scientist at the 3M company, was attempting to develop a super strong adhesive. Instead, he accidentally created one that was incredibly weak. The adhesive could stick to surfaces but peeled off cleanly without leaving any residue, and it could be reused multiple times. Silver found the adhesive fascinating, but struggled to find a practical application for it. For years, he promoted the discovery internally at 3M, but nobody could figure out what to do with a glue that was not particularly good at gluing things. Then, in 1974, a colleague named Art Fry had an idea. He was frustrated that the bookmarks in his church hymnal kept falling out. He remembered Silver's adhesive and applied it to small pieces of paper. The result was a bookmark that stayed in place but could be removed without damaging the page. 3M launched the product commercially in 1980 under the name Post-it Notes. Today, billions of Post-it Notes are sold every year, proving that a failed adhesive can become one of the most useful office tools ever invented. Each of these discoveries carries the same quiet message. Progress does not always arrive through the front door. Sometimes it slips in through a crack, wearing the disguise of failure, contamination, or an ordinary inconvenience. Fleming's mold, Röntgen's mysterious glow, Spencer's melted chocolate, de Mestral's stubborn burrs, Fahlberg's sweet hands, and Silver's weak glue all share a common thread. They were noticed. The scientists and engineers behind these discoveries did not dismiss what they saw. They asked why, and that single question changed the world. Curiosity is not just a trait of great scientists. It is the engine of discovery itself. The next world-changing breakthrough might already be happening right now, in the form of something unexpected, something that looks like a mistake, waiting for someone willing to stop and ask the right question.